Thank you, Glenn, for your kind introduction. You know, since I've been here, people ask me a question. Why are you here? Aren't you supposed to be working to fix your company? Well, quite contrary to the rumors, we are far from dying. Just stop selling our stocks. You know who you are. I'm talking to you, Bob. Okay. Just stop, right? Bye. Okay. Anyway, so the true embodiment of obsolescence is in the form of PCN, right? We should know what that is. It stands for Product Change Notification. It used to be called PDN, or Product Discontinued Notification. I guess they just changed it to be more generic, and they can stuff other things in there, but we know what it is. And it's usually in the form of a PDF. It comes to us, and from the suppliers, it lists the part numbers to be obsolete, and the last date, you can still order them, right? It is specific because it has all the part numbers. It's time-bound. There's a time, the last day you can act, and it's measurable because you can compare with your BOM, your bill of material, and see what is the hit rate on your product, right? So we talk about is specific, it's time-bound, it's measurable. Great, right? Great stuff. But, you know, how many of you really look forward to getting this PDN? Whether you like it or not, it's going to come. And I probably want to see a show of hand. How many of you have learned about 2,000 or more part numbers are getting obsolete through this PDN in the last 12 months? Quite a few, right? So this is the kind of magnitude we're dealing with. And like I said, whether you like it or not, it will come. It's going to get worse, right? And you better get ready for it. There's something like, to me, there's something like your tax bill, right? You better get ready is another three-letter word, except it is worse. Why? Because your tax bill, for most of us, is a personal exercise. This PCN, it takes a team to digest. Now, the question is, how do you get ready? Well, the PCN is coming to you, the sky is dark. You might want to look for solutions around you, right? And when you look around for the solutions, it's not always clear. It's kind of muddy, right? And last time buy, the redesign are usually the kind of things that comes up, right? So, one time, a colleague of mine used to tell me, if the dollar amount is low, I would do a last time buy. If the dollar amount is high, I'd go for a redesign. Because as I will show you, it's not always clear what the solution should be. And number two, there are many solutions in between, actually. I would like to show you first what are other solutions available to us. On the right, you know, there are lists of solutions that are available to us. On the top, we have do nothing. Sometimes do nothing is a valid option, right? This is a kind of happy scenario we all hope for, but often it's not the case. It's appropriate if your product is going obsolete very soon anyway, right? It's not your concern, just don't do anything. Last time buy, we all know what that is. Die bank is another form of last time buy where you buy the half-finished product, you stock it, and then instead of the completed product, and it's been done, is for lower cost. And then second and third AVL, you go out and look for replacements for your drop-in replacements for your current product. You know, we try that as a high on the list of things to try. And up-spec, what that means is there may be a more recent product that are higher spec and hopefully cheaper as well. That's a valid replacement for what you're using, right? Close fit is something physically is a close dimension. It can still fit on the footprint on your PCB, right? And this valid for something that's simple, like a capacitor, resistor, some simple device that work. And MPI is a new product introduction. A lot of times there will be new product planned to replace your old product. You can check the when it's coming. That's often done. And then we can go to brokers, right? Brokers are the ones we all know about. There are certain risks associated with them. In the morning, we spend a lot of time talk about what those risks are. And then reclamation. Reclamation means you go out and take a working component out of a decommissioned system, right? And redeploy it to service to some other cases. And it's been done. Actually, there are companies, just their business model is reclamation, and it is appropriate for cases where the volumes are very low and far in between, right? GE does it, and there are outside companies doing that as well. And finally, minor redesign and major redesigns, right? There are minor redesigns, meaning you just change a footprint on your PCB, you don't change a circuit, and you don't affect the major components or circuit design. See, notice I put it in all in the same font, but if the font size is proportional to how frequently they are employed, there will be a very large font for the last time buy. It probably occupy the 70–80% of the page. Why? Because to me, it's just like a black hole. There's a strong gravitational field pulled everybody towards it and say, come to me. Why? It is easy, right? Design engineering doesn't need to do anything. And then if you have the budget, you buy it, and sourcing to get the problem over with. But there are a lot of problems associated with last time buy. I want to hear, can anybody give me a shout out on what are all the problems associated with last time buy? E&O. E&O, what that stands for? Excess and obsolescence. Okay. Anything else? Right. Expenditure, right? Funding surprises. Long-term storage, it may expire, right? Not the device, but the package may expire. You get oxidation and other things that you may need to check when you actually want to use it, right? Anything else? Shelf life, right? So a lot of things, but my point is, it is convenient, but there's many drawbacks. You either buy too much, too little, and then the finance people, ultimately, they will come to you and why you are having so much last time buy on our book, right? And well, my point is, if you start with the PCN and find your way through one of these solutions, it's a very hard and frustrating experience, right? I'm not advocating to any one of these solutions. The point is that any one of these solutions could be appropriate to your product. The point is, how do you find out ahead of time, hopefully, what is the right thing to do, right? So next, I want to talk about a proactive approach I will put in front of you. This is to start with something you know that's in your control. How about start with your product that you know about, right? Of course, it's not enough. You need to have the PCN information. You need to have the information from the ECD. ECD stands for Electronic Component Database, like Silicon Expert. They have a booth down there. They'll be happy to sell you something. It's needed. I'm not minimizing it, of course. We need the engineering insight. We need a design document, how complex the design is, how did it used, the supplier information, right? What is their roadmap, how long they will support the product, and the manufacturing data, right? And that will help us to figure out what the right solution is for your product. For the rest of my presentation, I'll focus on what's in that maze. What can we make sense of what could be in a maze that is a process and a framework that may be able to work, or actually we find it working, and hopefully you'll agree. So before I get there, I want to just have a few words about the advantage of early warning. Because in obsolescence, we're competing with time, right? Would you agree? Right? The more time we have ahead before the event, the more options we have, the more we can prepare. So by the early advantage, we can have the visibility of the risk. By doing that, we can look at impact, the timing of the MPI. By doing that, we can reduce or eliminate the bridge buy or last time buy. We can do, time will help us for the resource and product planning, and time will help us avoid funding surprises and find the best solution. I want to give you one example. Just about a couple or 3 weeks ago, a colleague of mine gave me a call and asked me to help him find an MLCC capacitor. It's a desperate situation. He couldn't find it anywhere, and it's needed for a production by the end of the year, right? So I helped him look at it. He had any replacement, anything, anywhere you can find it. And it turned out it is a specialty MLCC capacitor. It's a specialty mil-spec, aerospace mil-spec capacitor. But it turned out the spec discontinued in 2005. And there's a new spec, replace that spec, right? And it's more available, it's cheaper, it's better. So first, he could have known it in 2005 instead of 3 weeks ago. Second, he probably have been paying too much all these years. And third, he has been chasing the wrong thing. And fourth, he could have used all this time to qualify something of a newer, better, and cheaper spec, right? That's the power of early warning. Just know ahead of time and get yourself prepared. There's a lot of benefit for doing that. So what is the framework? So this is a framework I want to put in front of you. I'd like to explain a little bit. It's a funneling framework. So why it is a funneling shape? The reason is we are looking for obsolescence hotspots. Not everything is obsolete, right? For companies like GE, we have thousands of part numbers. And we need to find a way to focus on where the problem is and apply our energy to it. So we start with products at the top. We talk about HLA meaning high-level assembly, and within it are the PCBAs. And we have the different layers. At the end, you can see from top to bottom, we want to find a solution that's appropriate for the PCBA that we're concerned with. And first, we have the product knowledge layers. Start with something you know about your product, and then a component knowledge layer. So in these layers, we look at some high-level parameters of the product, the components. I'll give you an example. How do we have a scoring system to score it on a risk scale from 0 to 100? And then with that information, we get into a trade-off analysis. That's more analytical and see, okay, what is the characteristics of the problem and what could be the right solution. And then there will be solution matching where we basically look at what is the cost, what is the solution, and what is the problem we're solving, I'm sorry. So just want to see is any question about, is it clear here so far, right? Okay. Next, I'd like to get into what is in this product knowledge layer starting from the top. We care about the piece price of the PCBA. We care about the EAU. We care about the BOM as a file. The BOM stands for bill of material, you should know. And then the age of the product, how long it has been in production. And then what is the planning for the rest of the residual life cycle? What is the service life? Is there MPI to replace it? Some high-level data to begin with. Is it the right product? We should spend more time. Next, we look at a component knowledge layer. There we look at a component spending, total component spend, what's the cost of each component, and what are at risk. So we can give the ECD, and it can give us a report on what are the supplier risks, what are the type of the components we're using, and what are the life cycle of the components, whether it's growth, mature, decline, end of life, or do not use for new product, right? So with that, we figure out, okay, if there's a component at risk, what are the alternates? And there's tools like Silicon Expert, it can tell you what are the alternates available for your product as well. Next, for the trade-off analysis, we can look at the saving and the mitigation cost. So basically, it's a benefit and a cost. This one is a little bit skewed towards redesign, right? Because for redesign, look at the mitigation cost, we need to look at the NRE, look at the design, manufacturing document, how complex, how risky it is, and what is the verification, qualification, and certification costs, right? So with that, we basically look at the saving, the cost, look at, what is the appropriate solution at the end, right? These are at the bottom are the solutions I've covered earlier in my slide. So with this, I would like to show you an example about how we assess the risk of our products. So this is a scoring system that we use. This is not the only way to do it, of course. You can do it the way you want. But we start with, these are the few things we care about at the product level: the piece price, the EAU, the age in production, and the remaining life cycle. We'd like to give a score for each category, give a score from 0 to 25. These are the translation table down there. The higher the score, the more the risk. And then when we add it together, we end up an aggregate score from 0 to 100, right? So for something, if you look at a piece price, for something it's a higher price, for the EAU, if the quantity is large, it just tells us that the impact is high. If something wrong with this product, we're going to have a high financial impact. So we give a higher score. If the piece price is high, the EAU is high. And the age in production is the older the product, the more likely it will be in a risk of obsolescence. And the remaining life cycle, the same thing. The longer it will stay in production, it will remain to be our concern, so we need to pay attention to it, right? So with this, it's not a hard scale, but it kind of gives us, when you have a lot of part numbers to work with, it segregates the ones that we need to pay more attention to prioritize versus those that may not be at such risk, right? So this is the scoring system. It applies to the product level layer, product knowledge layer, and the component knowledge layer. And then for the analytics, on the trade-off analysis, here's one example. The question here is redesign or last time the right solution? We're trying to weight the two of them. So the blue is for redesign, the red is for last time buy. And it's measured on the delta, on the cost delta on the piece price over time. So if we look at the last time buy, the cost delta for last time buy initially is 0, but it will go up over time, right, because of the present value effect. After all, we are spending a bunch of money and put it on the shelf. It doesn't generate interest. So the longer it goes, we wait to use it, the more expensive it gets. And also, you notice for last time buy, once you start the last time buy, you're locked in to that strategy. Because 5 years later, you may have another last time buy, 7 years later, another last time buy. But because of the previous last time buy, guess what? You have to continue, right? And for the redesign, typically we get some cost saving initially because the new components are cheaper, likely. And then we get deflation, expected deflation over time, because using the newer components are going to be cheaper than the older components. And then we have suppliers tell us, you have been using our old components, we have no more deflation to give you, right? But the newer components, yes. So there are NRE and certification costs. Not for you, not to you, Ron, specifically. So we have NRE and certification costs we have to take into account. And it's typically we want to amortize it within the first year. And how much it is, it depends on your EAU, right? How much it will spread to the unit cost. We have to take that into account. So combining the curves, we have a curve for the redesign and a curve for last time buy. So the redesign in this case is you actually have to pay more the first year or so, and then you get some savings afterwards. Actually, if we just look at the net saving for redesign, it's actually more because not only you get a component saving, but also you get a cost avoidance for last time buy, right? And so that's why the curve is getting steeper, getting into the future. And finally, we have to take into account the volume reduction over time for your redesigned product, and then we modulate it so the saving is actually perhaps not as much, right? So it's not complex, but it does rely on the fact that from the previous layers, you know the facts and information that you have to work with. And then this kind of analysis is not that hard at all, right? So here I put them all together. I guarantee if you stare at it long enough, it makes sense. Yeah. Yeah, so my point is they're all connected. They're all connected. You start from the top with your product, it flows down, you know what goes into what, and then you can do some proper accounting, right? So if we just say we take a path and take a PCBA, we go to the BOM, and then from the BOM, we go to the feed into the ECD. It can tell us the information of the components, the alternates, and then they also can figure out what is the replacement, what is the saving, and then feed into the mitigation cost. And then feed into the analysis, it tells you what is the available options and the associated costs. The most cost-effective solution will end up to be your best solution, right? So, not to dwell too long on that, first, this is my conclusion, right? First, you need to have a strategy. You may not agree with my framework or what I've presented, but I think you need to have a strategy instead of waiting for the PCN to hit you. And understand your product's obsolescence risk, right? And choose a solution appropriate to your product. Because every solution, every option has a benefit and a cost, right? If you know the one, you can choose the one to be most appropriate to yours. And I think if you have a strategy, you plan ahead, and you get ready, put it on your dashboard, for example, I believe you will be ready. Okay? With that, any question?
Any questions for Sam? Yeah, I know your question. You want those slides, don't you? Anyone? All right, give it up for Sam. Oh, wait. Going once, going twice.
So I saw you did a calculation on how much each of your PCB boards was valued at. You had a formula. And do you rate them based on, do you then clump them together and try and figure out what the total risk is if you do a design for everything and how often you do that for a redesign for the whole product instead of just the individual components?
Right. Thanks for asking that question. So the problem is there are many heterogeneous parameters associated with a product. This scoring system is trying to map them on a uniform scale so they can be compared more easily, or you can sort them easily. So that's the point, right? Of course, the actual scale you can adjust for your product portfolio. right? For me, $1,000 may be an expensive product. For you, maybe $10,000, right? You can adjust the scale, but the point is, you take into account the cost, the volume, the age, the remaining life cycle, and you give it an assessment. How much risk this particular product is exposed to, right? And then you compare it with the rest of your product and see. Because if you have unlimited resources, sure, you can peanut butter your resources over everything, but it's usually not the case. We like to prioritize it. Number two, you would need to work with other departments like your component engineering, design engineering. You want to show them you have a plan. You have a strategy. You don't want to go to them and say, hey, I got a problem. Can you solve this problem? And say, when are you going to come back again? And I can't do it on demand, right? But you explain to them, what is the problem we're solving, how big the scope is, what you can expect down the road. You have a better conversation.
Any other questions? There we go.
Sorry. So I think on that same thread, right? So if you're talking about redesign, when you quantify the redesign costs, you're looking for your engineering team to quantify that redesign cost. And do they also bring in potential redesign of major assemblies that goes into, an additional redesign, not just for that isolated part, but for anything that is affected by that?
Yeah, you bring up a good point. Okay, redesign engineering team, right? Normally, when it comes to redesign, you will get a lot of pushback from the engineering team. So for that, we would like to give them some help, right? We'll get involved some other suppliers or help to assess the product and say, okay, what is the NRE, how long it takes, and what we need from you. So for us, for example, we try to lighten the load for our engineering department by saying, okay, we'll find some help to do some heavy lifting, like changing the schematic, the layout, doing the bring up qualification. We just need you to be a part of it because you still know the product the best, right? We need you to review, for example, approve what we are being changed, what's being changed, and then eventually they will need to do some system validation, right? So the point is, engineering teams are usually heavily tasked, right? So we try to find a path that's workable for them and good for the company, right? So involve them, not for everything, hit them with everything and say, okay, we have a proposal from the supplier, and this is what they can do. This is what's the cost, and what we need from you. So it's really a collaborative approach.
Go ahead, Sam.
Yeah.
I got a question. So it sounds like there's a lot of work involved to get this thing done, this analysis done, correct? So how many, have you done quite a few of this analysis to the extent that you're talking about? And and how long does it, I mean, to me, it looks like it's quite extensive work versus let's just go get some additional devices and do a last time buy and we're done.
Yeah.
Let the CFO cry for a few minutes.
Yeah, good point, right? Good point. So here's the idea, right? So you're right that if to do a complete analysis for every board is a lot of work. But we start from something that we can easily assess first, right? You go to source and they can easily come up with the information, how much we're spending, what is the EAU, what's the age of the product, what is the, how much longer, at least they can guess how much longer they'll continue to produce it. And then with that information, we have a good idea, how much risk it is at. And then for the BOM, for the component, as long as we can get hold of the BOM, we can feed it into the ECD, right? So you can give us a report. So the workload getting gradually becomes heavier and heavier. That's why we have a funnel shape and try to not to work on every part the same amount of work, but we gradually apply more work to the ones that matters. Yeah.
Okay, one last. There we go. You have right over here.
if you're going to do a replacement of a part instead of an LTB, do you still go through that entire analysis for risk?
We do. Sometimes last time buy is probably the best solution, right? I have nothing personally against last time buy, but the question is it a right solution? We just don't want to make it a solution for everything, right? If somebody come to you, I give you a choice. You either do a last time buy or stop your production. It's not a choice, right? So, but I wanted some real choice. So other than last time buy, what else can I do, right? So maybe last time buy is the right solution. Let's go for it.
All right, give it up for Sam Wong.